Hello everybody. I don't know about you, but I had quite a rough day. And you know, there's nothing that's going to make me relax quite like doing a little bit of trigonometry. So let's talk about one of the things that I know best about trigonometry, and that is Pythagorean triples. Pythagorean triples. Now, likely you've heard of these before. If not, these are three integers, positive integers that is, that fit the Pythagorean theorem. Now the formula associated with the Pythagorean theorem, as you probably recall, is a squared plus b squared is equal to c squared. Now, there's a lot to be said about this, but I won't waste your time. I want to get into Pythagorean triples. The most simple Pythagorean triple is what's known as the 3, 4, 5 triple, meaning if I plug in 3 for A, and 4 for B, and 5 for C, I can show that the Pythagorean theorem holds true. 3 squared is, of course, 9, 4 squared is 16, 5 squared is 25, and 9 plus 16 is also 25. So 3, 4, 5 is a Pythagorean triple, as those integers fit the Pythagorean theorem. There are several others, 5, 12, 13, for example. And we can show that 5 squared plus 12 squared is equal to 13 squared. 25 plus 144 is equal to 169. And 25 plus 144 is 169. Now these are just two, I would say the two most basic Pythagorean triples that we have. How many Pythagorean triples are there? Probably infinite. I don't know if it's ever been proven that it is definitely infinite, but it's certainly more than you could ever possibly need. So how do we figure out what the Pythagorean triples are? Well, there's a pretty cool little formula for that. Now, for any Pythagorean triple, all you need are two integer values, both positive, s and t. So s and t are elements of the set of integers, and also we're going to say that s is greater than t. Now, with this being the case, we can generate three values. One is going to be s squared plus t squared. I'm not putting that in parentheses. I can have a second value of s squared minus t squared. Oops, I wrote a 2. S squared minus t squared. And the last one is just going to be 2st. So if I pick two values, I'm going to go with 4 and 1. So if s is 4, we get 4 squared plus 1 squared. We get 4 squared minus 1 squared. And we get 2 times 4 times 1. That doesn't look very good, and we can do better. So if we can do better, we should do better. 2 times 4 times 1. 4 squared plus 1 squared, that's 17. 4 squared minus 1 squared, that's 15. And 2 times 4 times 1 is 8. So in reverse order, we are implying that 8, 15, 17 is a Pythagorean triple. Well, first let's check it. 8 squared plus 15 squared is equal to 17 squared. 8 squared is 64. 15 squared is 225. And 17 squared is 289. 64 plus 225 is 289. So we can show that 289 is equal to 289. So it worked. Why does it work? Well, here's where we get a little bit heavier with how we look at things. So I told you that the three values are s squared plus t squared. And we also have s squared minus t squared. And we have 2st. Now this top one, that's always going to be the biggest values. So when we square all three of these, these two are going to be the ones that we end up adding. So let's see if we can create a proper formula. 2st, one of the smaller values, squared, plus s squared minus t squared, squared, is going to equal s squared plus t squared, squared. If I square my very first term that I have here, I wind up with 4s squared t squared. For the next part, I have a binomial that's being squared. So what we wind up with is s to the 4th minus 2s squared t squared and plus t to the 4th. Zoom out to give myself a little more room here. So s squared plus t squared squared, what that's going to wind up being is s to the 4th. I can make that look better. S to the 4th plus 2s squared t squared plus t to the 4th, just by expanding that binomial. I would like to leave the right side alone. So let's operate on the left side. You'll notice I have an s to the 4th. I have this was supposed to be t to the 4th. My apologies. This one I'm not going to make look better. That's a 4 now. I have a plus t to the 4th. And I have 4s squared t squared and minus 2s squared t squared. Those are like terms. And when I combine those, 4 minus 2 is 2. So what I wind up with is s to the 4th plus 2s squared t squared plus t to the 4th. And that equals, well, look what I already had on this side. S to the 4th plus 2s squared t squared plus t to the 4th. Same thing on both sides. So this implies that this would work for any s and t, even if they were not integer values. And while that is true, generally speaking, when we're talking about Pythagorean triples, we are talking about Pythagorean triples in regards to integers, though there is a case to be made for certain decimal values as well. Certainly, if we were to scale a Pythagorean triple and instead use something like 0.3 squared plus 0.4 squared, that would give us 0.5 squared, or 0.09 plus 0.16 is equal to 0.25, and that is also true. The last thing to say about this is the idea of the primitive Pythagorean triples. When I gave you the conditions for using that formula, I only said that s and t needed to be integers and that s needed to be greater than t. Well, there are two other conditions that are often used, and the first is that the greatest common denominator between them, so g, c, d, of s and t, must be 1, meaning they are co-prime. Not necessarily either one of them is prime numbers, though certainly they can be, but they must not share any factors in common in order to be a primitive Pythagorean triple. The other thing is that s and t have different parity. I'm just going to abbreviate here, different parity. I hope I'm spelling that correctly. And all this means is one is odd, one is even. It doesn't matter which is odd and which is even, but one must be odd and one must be even. So let's take a look at an example where maybe these conditions aren't met and compare them to a situation where these conditions are met. So I would like to use 4 and 2. So if I use s is equal to 4, my values then are 4 squared minus 2 squared, 2 times 4 times 2, oops, I wrote a t, and 4 squared plus 2 squared. So 4 squared minus 2 squared, that's 16 minus 4, or 12. 2 times 4 times 2, that's 16. And 4 squared plus 2 squared, 16 plus 4 is 20. So 12, 16, and 20. 12 squared is 144, 16 squared is 256, 20 squared is 400. So of course, those work out. I apologize for not showing, but I wanted to leave room to show what happens if we just divide all of these values by 4. 12 divided by 4 is 3, 16 divided by 4 is 4, and 20 divided by 4 is 5. 3, 4, 5 is a primitive Pythagorean triple, whereas 12, 16, 20 is just a multiple of this primitive 3, 4, 5. How do you get 3, 4, 5? Well, instead of using 4 squared and 2 squared, let's cut each of those in half. 2 squared minus 1 squared. 2 times 2 times 1, and 2 squared plus 1 squared. We get 3. 2 times 2 times 1 is 4, and 2 squared is 4 plus 1 squared is 5, and that's where 3, 4, 5 comes from. Well, I hope you learned a little something today. I hope you were able to relax. I hope that the background sounds weren't too distracting as they were to me. If you're still awake, please like and please, please, please subscribe to this channel. And if you're asleep, good for you. I hope you sleep great and you wake up tomorrow feeling refreshed and maybe just a little bit smarter. Well, until next time, keep on mathin'.